The hardest things to factor are when we have three terms, but a is not equal to 1. And there are a lot of methods out there. There's a tic-tac-toe method. There's a factoring by grouping, which I will tell you about on the next slide. On this one, I'm going to talk to you about a method that I call amazing factoring, because this can be really difficult, but I think using the amazing method, it's actually pretty straightforward. So here's what I'm going to do. I'm going to take a times c, which means we know that a here is 6 and b is 1 and c is -2, because again, we're dealing with a quadratic, ax squared plus bx plus c. And again, we always want to equal to 0 when we start. So I'm going to take a times c, so I'm going to take 6 times -2 to get -12. On the last one, remember, I looked at numbers that multiplied or added to whatever. So what I'm looking for here is I'm looking for numbers that multiply to -12 that have a difference of 1. So again, -12 could be 1 and 12, 2 and 6, 3 and 4, etc. Do any of those have a difference of 1? Yes. And I want it to be a +4 and a -3, because I want the difference to be +1. So -3 plus 4 is 1, and -3 times 4 is -12, which is this number, so not c, but a times c. Now, using the amazing factoring all has to do with a, because what I'm going to do is I'm going to say this is x minus, and then I'm going to put whatever my numbers are over a. So 3 over 6, and then x plus 4 over 6. Now you might be saying, okay, Professor Brame, no thank you, you just had me deal with fractions. Well, yes and no, it's actually not so bad. What I'm going to do is I'm going to say, well, 3/6 obviously reduces to 1/2, and 4/6 obviously reduces to 2/3. And it's still not quite the format that I want. So what I'm going to do is if I'm left with a fraction, which I am, I'm going to look at these denominators and just stick the denominators out front. So what I have here is 2x minus 1 and 3x plus 2. So all I did was take the denominator and put it in front of the x and then make the numerator just a whole number. Now, if you don't believe me, we could multiply this back out. 2x times 3x is 6x squared, just foiling. 2x times plus 2 is plus 4x. Minus 1 times 3x is minus 3x. Minus 1 times 2 is minus 2. And if I simplify, I get right back where I started, which is of course what I wanted. So that's amazing factoring. Now, did I solve yet? No, of course I didn't. I kind of ran out of room. But if I solved, I would set 2x minus 1, 2x minus 1 equal to 0. So I would add 1 to each side and then divide by 2, so x is 1/2. And then I would set 3x plus 2 equal to 0. So I would subtract 2, and then I would divide by 3. And so those would be my two solutions, is 1/2 and -2/3. So quite often your answers will be fractions when you're all done, and don't freak out about it. For my next one, first thing I would do is right away I see that all of my values are even, so I'm going to take a 2 out of everything. And I'm also going to rewrite it in the proper form because I really want this to come first. So that's going to be 3x squared, and then minus 4x except divided by 2, so minus 2x. And then minus 16, but divided by 2, so minus 8. So now a is 3, b is -2, c is -8. So what I'm looking for, again, is I'm going to take a times c, which means I'm going to take 3 times -8, which is -24. And I'm looking for numbers that multiply to -24, and I want them to have a difference of 2. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I found my winner. I want it to be -2, so +4, -6, which means my factorization is, keep the 2 on the outside, don't lose it, x plus 4 divided by a, and then x minus 6 divided by a. So remember, a is 3, so I'm always dividing by a because it's a amazing factoring. For my first one, 4/3 doesn't reduce, so I'm popping the 3 out front, 3x plus 4. And for my second one, 6/3 actually does reduce to 2, so I'm just going to leave it as x minus 2. Again, these should all be equal to 0, and then I would say 3x plus 4 equals 0, so 3x is -4, x is -4/3, so that's one solution. X minus 2 equals 0, x is 2, that's my other solution. So that is how we solve by factoring using the amazing factoring method. Now keep in mind that Alex, your program that you use in this course, will probably explain it in another way, and if that way makes more sense to you, I'm perfectly fine with you using it.